Deep within the lush, emerald canopies of Southeast Asian rainforests, a creature moves through the air in a way that defies conventional understanding. It has no wings, no feathers, and no limbs, yet it undertakes remarkable aerial journeys between towering trees. This is the flying snake, a master of the air that challenges our perception of what a serpent can achieve. Its unique method of traversing the vertical world is a testament to the astonishing possibilities found in nature, a spectacle of physics and form working in perfect concert. How does a snake, a creature typically bound to the ground or branches, navigate the open air with such uncanny grace? The answer lies in a series of precise movements and an extraordinary manipulation of its own body. The rainforest canopy is a vibrant, interconnected world, yet for many creatures, crossing the gaps between trees presents an insurmountable challenge. For a snake, typically built for slithering or climbing, these arboreal chasms would seem like impassable obstacles. However, the genus Chrysopelia, commonly known as flying snakes, transforms these aerial voids into its personal highway. Their habitat demands a specialized form of locomotion, and they have developed an astonishing capability to navigate this three-dimensional environment with ease. It's not true flight in the avian sense, but rather a highly controlled, aerodynamic glide that allows them to cover significant distances. To be precise, these snakes do not fly in the way a bird or bat does by actively generating thrust. Instead, they glide, utilizing gravity and manipulating air currents with their body shape. Imagine a skydiver, but one who can transform their body into an efficient aerodynamic surface. The flying snake initiates its movement by launching itself from a high point, then reconfigures its body to reduce drag and generate lift. This distinction is crucial to understanding the underlying physics of their remarkable journey through the air. Their method is a finely tuned active controlled descent, a testament to biomechanical ingenuity. The aerial journey begins with a deliberate act, the launch. From a high branch, the snake propels itself outward, sometimes forming a J shape with its body to gain initial momentum. This initial thrust is critical, providing the necessary velocity to overcome static air and begin its descent. It's not a mere fall, it's a calculated leap, often angled sharply downwards, to capitalize on the force of gravity while simultaneously preparing its body for the aerodynamic transformation that follows. The precision of this takeoff sets the stage for the entire glide, demonstrating an inherent understanding of the mechanics required for successful aerial navigation. Immediately after launching, the snake undergoes an extraordinary physical transformation. It dramatically flattens its body along its entire length, from neck to vent, almost doubling its width. This isn't just a passive flattening, it's an active muscular exertion. The ribs, typically designed for flexibility in movement and constriction, are extended and rotated, pulling the skin taut and creating a concave shape on its underside. This remarkable structural change is the first key to unlocking its aerial capabilities, turning a cylindrical body into a broad, aerodynamic surface. Without this initial metamorphosis, a controlled glide would be impossible. The flattened body of the flying snake is not merely a flat surface, it is sculpted into a highly effective aerodynamic profile. In cross-section, the snake's body assumes a shape remarkably similar to that of an airplane wing, or airfoil. The concave underside, paired with a slightly convex upper surface, creates a pressure differential when air flows over and under it. Air moving over the curved top surface travels a longer distance, causing it to speed up and creating lower pressure above the snake. Conversely, higher pressure beneath pushes the snake upwards, generating lift. This ingenious form allows the snake to ride the air. As if the flattened body isn't remarkable enough, the snake introduces another critical element, a continuous, undulating S-curve movement of its body. This isn't just for show, it's a sophisticated technique that enhances stability and control. The snake continuously oscillates its body both horizontally and vertically, creating what scientists refer to as a dynamic wave through the air. This active undulation is vital for two reasons: it maintains stability in flight, preventing tumbling, and it generates subtle shifts in air pressure that contribute to lift and allow for precise adjustments to the glide path. It's a dance with gravity and air. The S-curve movement is complex. The snake's anterior body undulates with a greater amplitude than its posterior, creating a ripple effect that travels down its length. This wave-like motion effectively grabs air, directing it over the body's flattened surfaces in a way that maximizes the efficiency of the airfoil. It's a sophisticated method of manipulating airflow, not just passively relying on air currents. This active control over air movement around its body allows the snake to fine-tune its lift and drag, making adjustments in real time to external conditions like wind gusts or turbulence. They are, in essence, surfing the invisible currents of the rainforest air. Beyond just generating lift, the flying snake exhibits remarkable control over its direction. By subtly altering the degree of flattening, the amplitude of its S-curve, and the orientation of its head and tail, it can steer its glide path with surprising precision. It can make turns, adjust its pitch, nose up or down, and even correct for yaw, side-to-side rotation, demonstrating sophisticated aerial maneuvering abilities. Researchers have observed these snakes making significant mid-air course corrections, guiding themselves towards specific landing targets. This level of control dispels any notion of their glide being a simple, uncontrolled fall. It is a highly directed journey. The flying snake's glide is truly exceptional when compared to other gliding animals. While flying squirrels use membranes of skin between their limbs, and gliding lizards deploy specialized ribs, the snake achieves its feat with no such appendages. It reconfigures its entire body, transforming a limbless, elongated form into a dynamic aerodynamic system. This distinction highlights the snake's unique approach to aerial locomotion, relying purely on muscular control and shape manipulation. It's a testament to the diverse strategies found in nature for navigating complex environments, pushing the boundaries of what is mechanically possible for a serpent. The efficiency of the flying snake's glide allows it to cover impressive distances both horizontally and vertically. Depending on the species and the launch height, these snakes can glide for tens of meters, losing relatively little altitude for the distance covered. Their glide angle, a measure of how steep their descent is surprisingly shallow, often less than 20 degrees. This efficiency allows them to cross significant gaps between trees, reaching speeds that can exceed 10 meters per second. This makes them highly effective at traversing the fragmented arboreal landscape of the rainforest. One of the primary benefits of this unique gliding ability is predator evasion. When threatened by an arboreal predator, such as a bird of prey or a tree-dwelling mammal, a flying snake can simply launch itself into the air and glide to safety. This sudden disappearance from the branch, followed by an unpredictable aerial trajectory, can disorient a pursuer and provide a crucial head start. It's an instant escape route, allowing the snake to rapidly change its location and escape imminent danger without having to engage in a direct confrontation. This remarkable agility gives it a significant advantage in the cutthroat environment of the rainforest. Beyond escape, gliding offers a highly efficient mode of transport. Climbing down one tree and up another can be energetically costly and time-consuming. A short glide, however, allows the snake to bridge gaps quickly and conserve energy. This is especially useful in fragmented habitats or when moving between foraging grounds. It provides a means to explore new territories or access isolated food sources without expending excessive energy. The flying snake essentially bypasses the terrestrial journey, making its arboreal lifestyle far more flexible and less constrained by the physical barriers of the forest floor. The gliding technique also serves as an effective hunting strategy. From an elevated position, a flying snake can observe prey below and then launch itself into a silent, swift glide, ambushing unsuspecting lizards, frogs, or even small birds on lower branches or the forest floor. The element of surprise, combined with its speed and precision, makes it a formidable aerial predator. This capability turns the snake into a dynamic hunter, expanding its predatory reach beyond what a ground-bound or purely climbing snake could achieve. It's a calculated descent, culminating in a sudden, decisive strike. While we often refer to the flying snake, there are actually several species within the Chrysopelia genus, each exhibiting this incredible gliding ability. From the paradise flying snake, Chrysopelia paradisei, with its distinct black and yellow patterns, to the golden tree snake, Chrysopelia ornata, known for its vibrant green scales, these different species share the fundamental mechanics of their aerial locomotion. Their existence across various parts of Southeast Asia underscores the utility and success of this remarkable form of movement in their specific ecological niches. Each species, though distinct, masters the same complex physics. A successful glide concludes with a controlled landing. Flying snakes typically aim for a vertical surface, such as a tree trunk. As they approach, they reorient their body, often flaring their ribs to slow down and creating a sort of parachute effect. The snake then uses its tail to brace against the impact, wrapping it around the trunk or a branch, and its scales provide the necessary grip to stick the landing. This precise deceleration and attachment demonstrate the complete mastery the snake has over its aerial journey, from launch to touchdown. It's a testament to the sophistication of its entire gliding sequence. The mechanics of the flying snake's glide have captivated scientists and engineers for decades. The ability of a limbless creature to not just fall, but to actively shape its body into an aerodynamic surface and undulate through the air with such precision, offers profound insights into natural engineering. It is a stunning display of biomechanical efficiency, using fundamental principles of fluid dynamics in a way that seems almost impossible for its form. This serpent's aerial prowess serves as a constant reminder of the incredible diversity of solutions found in the natural world to overcome environmental challenges. It's an ongoing puzzle and a source of wonder. The study of flying snakes is not merely an academic pursuit, it holds significant potential for biomimicry and robotic design. Engineers are constantly seeking inspiration from nature to create more efficient and adaptable machines. The snake's ability to change its body shape dynamically and control its glide without rigid wings could inform the development of novel aerial robots for surveillance, exploration, or search and rescue operations in complex environments. Imagine a future where robots, inspired by these amazing reptiles, can navigate dense urban canyons or disaster zones with similar agility and precision. The implications are far-reaching. The flying snake, in all its improbable glory, stands as a true marvel of the natural world. Its ability to transform its body, harness air currents, and navigate the rainforest canopy without wings is a testament to the astonishing breadth of forms and functions found in nature. It reminds us that even the most seemingly constrained body plans can achieve extraordinary feats through precise biomechanical principles. It is a living lesson in aerodynamics, demonstrating that with the right combination of shape, movement, and control, even a limbless serpent can soar. Its silent glide remains one of the rainforest's most breathtaking secrets. From the initial leap to the perfect landing, the flying snake executes a complex and highly coordinated sequence of movements, demonstrating an innate mastery of fluid dynamics. It transforms its body from a slender cylinder into a dynamic airfoil, then undulates through the air, steering with precision, and using gravity as its ally. This silent, wingless flight is not just a curiosity, it is a vital survival mechanism, enabling escape, efficient travel, and effective hunting within its arboreal domain. The flying snake continues to inspire awe and curiosity, a captivating example of how life on Earth continues to surprise us with its boundless ingenuity and grace.